Module 1, Lesson 13, Exercise 6. We're going to look at an equation with a third power this time. X to the third plus 2 equals 2x squared plus x. First thing we're going to do is decide whether or not possible solutions are 1, -1, and 2. We're going to do that using substitution. So we'll start with the first question, and we're going to put 1 in. Notice I put 1 in for the x cubed, 1 in where it's x squared, and 1 in for x. That's substituting. And now I'm going to simplify, which means do a little multiplying. I get 1 plus 2 equals 2 plus 1. Nice, that's true. Now I'm going to go ahead and do the same thing, but where I put 1, I'm going to put -1 this time, because now I'm going to do x equals -1. There it is, -1 cubed, -1 squared, and -1. When we simplify, we get another lovely answer, -1 plus 2. The -1 turns positive here, -1 turns -1, so we still have 2 minus 1. That's true statements, 2 and -1. So, last one, put 2 in. 2 cubed, 2 squared, 2. 2 cubed is 8, 2 squared is 2, 2 squared is 4, times 2 is also 8. This one looks like we have the potential for a good answer too. 8 plus 2 equals 8 plus 2. True. So Bonzo's this guy who's got a new rule. He thinks you can ignore the exponents on each side of the equation. So he takes the equation x cubed plus 2 equals 2x squared plus x and translates it to x plus 2 equals 2x plus x. What we want to do is find out what his answer would be if he solves this problem. So let's have a look. First of all, the equation he has to begin with. We combine the x's on the right-hand side. X plus 2 equals 3x. We can remove one x from each side. We get 2 equals 2x. And we find out that 1 is what x is. Excellent. Well, it'd be great, except for that up here we've already proved that we should have a -1 and a 2 in this answer as well. So what we know is that it means we might get only one answer, and above we found that we had a 2 and a -1, which were also solutions. It's probably not safe to assume that we can ignore the exponents. But let's go ahead and try one more thing. What if he applies this method to another situation? Will we get the original? Is it the solution to the original equation? Let's find out. So using his method, we would say that it now becomes x plus 4x equals 2 plus 2 equals x. Nice. Okay. That gives us 5x plus 2 is x, which gives us 2 equals -4x, which gives us -1/2 for our x. Well, this isn't going to be pretty, but we're going to have to put -1/2 in for the x. Here, here, and here. It'd be nice here, -1/2 of 4 is -2, and that gives us 0 pair. But is that going to do it what we need? So inserting this new answer into the original makes quite a mess of things, and in the end, if you look, makes it quite false, because again we said these two were 0 pair, but -1/2 squared is 1/4 and -1/2 to the 4th is 1/16. Not true.